Maneuvering during slow flight with only the use of instrument references is a good way to improve your scan and become smoother and more precise with the controls. Remember, there are two basic methods for attitude instrument flying: the control and performance method and the primary and supporting method. We'll take a look at each technique and how they can be used simultaneously to successfully complete this maneuver. Let's start with a brief review of the control and performance method. When we're talking about the control and performance method, we break the flight instruments into three different categories: control, performance, and navigation. The control instruments will be the attitude indicator and the tachometer. The performance instruments will be the airspeed indicator, altimeter, vertical speed indicator, and rate of turn indicator. Navigation instruments will not be important for this maneuver unless you're attempting to navigate during slow flight. In that case, the CDI, HSI, glide slope indicator, or moving map display would be used for navigation purposes. The primary and supporting method also divides the instruments into three different categories, but instead of control, performance, and navigation, we have pitch, bank, and power. It will depend on the maneuver you're performing as to which instruments you'll rely on primarily and which ones will play a supporting role. The control and performance method provides the basic means by which we fly the airplane. The primary and supporting method allows us to more efficiently scan our instruments and verify that the plane is doing what we want it to do. Now let's get into the maneuver itself. Select an altitude that will allow the maneuver to be completed no lower than 1,500 feet AGL. Perform your clearing turns so your instructor can check for traffic. Instead of identifying a visual reference to maintain your heading, you'll use your heading indicator. Note the altitude and heading you're flying and reduce the power to 1,500 RPM. If you're doing the maneuver with the flaps down, make sure you're below the VFE for flaps 10 or 110 knots and make the appropriate call out. Extend the flaps to 10 degrees. As you extend the flaps, be sure to adjust the pitch slightly lower on your attitude indicator to compensate for the increase in lift that the flaps will generate. Below VFE for flaps 30 or 85 knots, make the appropriate call out and extend the flaps to 30 degrees. Just as before, anticipate the increase in lift the flaps will create and push forward on the yoke to lower the nose momentarily so you don't inadvertently gain altitude. As the airspeed continues to decrease, increase the pitch on the attitude indicator so the plane maintains altitude. At this stage in the maneuver, here's how you should be using the control and performance method. Your control instruments are going to be the attitude indicator for pitch and bank and the tachometer for airspeed. The performance instruments will be the altimeter for pitch, heading indicator for bank, airspeed indicator for power. Now let's consider the primary and supporting instruments. Primary for pitch is the altimeter. Supporting is the attitude indicator and vertical speed indicator. Primary for bank is the heading indicator. Supporting is the attitude indicator and the turn rate trend vector. Primary for power is the tachometer, and supporting is the airspeed indicator, until you reach the desired airspeed. And then the airspeed indicator becomes the primary instrument and the tachometer is relegated to a supporting role. Once the airspeed has slowed enough to activate the stall horn, increase power to approximately 1900 RPM and set the pitch to maintain the minimum airspeed, approximately 2 knots above the speed at which the stall horn activates. Don't forget to reset the trim to relieve control pressure and help maintain the desired airspeed. If you're performing the maneuver in the clean configuration, except for the steps involving flap extension, the procedure will be the same. However, you'll need less power once established at the desired speed because the plane will be in a lower drag configuration with the flaps retracted. An RPM of approximately 1,700 should get you close to the speed you need to maintain. When the plane has been slowed to the appropriate speed and trimmed for level flight, climbs, turns, and descents should be performed using the radial scan technique. This technique revolves around the attitude indicator and lets you cross-check instruments with very little eye movement. For example, if you were to make a standard rate turn to an assigned heading, you would control the plane by rolling in using the attitude indicator for both pitch and bank information and the tachometer for power. All the information we need to monitor the airplane's performance is conveniently located in close proximity around the attitude indicator. That's why the radial scan technique works so well with the G1000. At the same time that you roll into your bank, you'll need to watch the turn rate trend vector at the top of the HSI to establish a standard rate turn. Once the standard rate turn is established, glance back at the bank indicator and note the bank required to maintain a standard rate turn. For altitude information, you would simply look slightly to the right of the attitude indicator to the altimeter and VSI, which will tell you your altitude and any vertical trend that may exist. If you've deviated from your altitude, make the appropriate pitch change by using the yellow chevron at the center of the attitude indicator, and then confirm that the proper adjustment has been made with the altimeter. Remember, pitch plus power equals performance. Anytime you do something with the pitch, you should also do something with the power, and vice versa. Bring your scan back to the attitude indicator, then to the left, where you can get airspeed information from the airspeed indicator. Return your scan back to the attitude indicator, then directly below it to get heading information from the HSI. Since the turn rate trend vector is situated in conjunction with the HSI, you can verify your turn rate at the same time you monitor your heading. If a correction is needed, use your control instruments to initiate the change, and then verify with the performance instruments that the desired change took place. Regardless of what maneuver you're performing, this method of scanning the instruments is an easy and effective way of controlling your airplane. Because of the slow airspeed and high angle of attack, maneuvering during slow flight should be performed with very smooth and measured control inputs. Sudden or excessive control inputs, especially pitch changes, should be avoided. Pitch changes of a few degrees at a time will help ensure smooth aircraft control. Use no more than standard rate turns when turning, unless your instructor specifically states otherwise. To return to normal cruise speed, smoothly increase power to full, adjusting the pitch to maintain altitude. Trim as necessary and maintain heading. If returning to cruise flight from a flaps down configuration, retract the flaps to 20 degrees. When at or above 60 knots indicated airspeed, retract the flaps to 10 degrees. Once above 65 knots indicated airspeed, fully retract the flaps. When you're within 5 knots of your cruise speed, set cruise power, retrim, and complete the cruise checklist.